favorite concept in myth, horror, or science fiction is the shapeshifter. These are humans or aliens able to alter their appearance or form. These characters might blend into their environment, impersonate other characters, or completely transform into an animal. This idea appears to be common among cultures all around the world, no matter how isolated. It must be something deep in our consciousness. Perhaps it is our wish to co-opt the power of wild animals such as bears or lions, or take on the perfect disguise for getting the best of others. There are skinwalkers, shapeshifters, vampires, werewolves, or gods of Greece, Egypt, or India that are part human and part beast. We've imagined parts of different animals blended together, like Frankenstein's monster or the Minotaur. But where does the fantasy end and the reality begin? We don't have too many examples in our world for comparison. The octopus would be my best candidate. First, they have fascinating mechanisms for altering their appearance. Octopuses can shift hues because they have chromatophores, tiny color-changing organs throughout an octopus's skin. At the heart of each chromatophore are tiny sacs filled with nanoparticles of a pigment called xanthomatin. The pigment sacs are surrounded by an elastic matrix that is, in turn, connected to muscle cells surrounding the sac in a pointed star shape. As these muscle cells contract, the pigment sac stretches, enabling more light to enter the cell and reflect off the xanthomatin particles. Because xanthomatin absorbs only certain wavelengths or colors of visible light, the light reflected is a different color than the light which entered the cell. There are 3 layers of chromatophores in an octopus's skin, each with xanthomatin particles reflecting a different color. The top layer produces yellow, the middle layer reflects red, and the bottom layer produces a brown color. Octopuses can combine these colors by changing the shape of the chromatophores in each layer, which enables the cephalopods to create a wide array of hues. This is analogous to a computer or television display with pixels consisting of red, blue, or green dots. Control of each of those dots determines the color and brightness of the pixel. Each individual chromatophore, up to tens of thousands or millions depending on the size of the species, is controlled by direct neural signals from the octopus's brain, causing the muscles surrounding the sac to contract or relax, changing its shape. The octopus's brain sends signals activating these muscles to open up the sacs. The combination of the chromatophores alters color of the skin. This is analogous to part of the octopus's brain acting as a graphics card running an LCD monitor. Perhaps there is a specific part of the brain doing just that. The brain of an octopus is partially distributed throughout its body. The colors also change remarkably quickly, much faster than those of a chameleon. Chromatophores aren't the only structures involved for changing color. Additional organs known as iridophores and leucophores in the skin of certain octopus species can help enhance or alter the colors they produce. Iridophores are slightly larger than chromatophores and help create octopuses more luminescent and metallic colors. Iridophores contain a protein called reflectin, which stacks up inside the iridophores to create a mirror-like effect. According to a 2018 study in the journal IOP Science, leucophores are similar in size to chromatophores but have specialized white pigments instead of xanthomatin, which scatter or refract light and help control the contrast and brightness of colors. Both iridophores and leucophores are expanded and contracted by neural signals from the brain, just like chromatophores. Octopuses also possess a mechanism in their skin that helps them to alter their texture, adding another layer to the camouflage. They have tiny bumps called papillae that can be relaxed, making the skin smooth like seaweed, or contracted, making the skin lumpy and rough like a rock. The papillae are also controlled by neural signals from the brain, but this texture-changing process is even less understood than color changing. Imagine if your computer screen not only changed images, but textures as well. The octopus is probably our best example of a shapeshifter. The animal can fit through almost any space large enough to accommodate its beak and its eyes. Many mammals, such as mice, can also squeeze through tight gaps, though not to the extent of invertebrates. This is where I have an issue with characters such as Odo, the security chief, or Deep Space Nine. He has the ability to ooze under a door or through small cracks, yet he can stand upright. How he changes his skeletal structure has not been explained. Another questionable area has to do with the transformation from one form to another. Examples here on Earth would be frogs, toads, insects such as beetles, butterflies, and moths, and some salamanders. We can follow the progress of the creature in Alien from egg to parasite, then the nasty chestburster. It's not apparent how long the gestation period inside the host might be. It must be several days or maybe a couple of weeks. That might be long enough to grow a creature weighing a pound or two. The question is, how does it grow from that stage to adulthood? This is also not explained unless the creature made it to the ship's food supply. Biomass has to come from somewhere. Again, the time frame between chestbuster to adult alien is unstated. Even though the adult is quite skinny, it must have several times the mass of the baby. At least in Alien, I don't recall any victims being between the time it escaped and when that lovely, drooling, jaw-snapping bloke appeared. Tadpoles or caterpillars have a remarkable ability for transforming their own tissues, but they do not develop into creatures with far more body weight than when they started. Tadpoles eat but do not take in enough energy to rearrange so much tissue. Please check out my previous podcast called Quantum Cabbages for surprising theories on how quantum mechanics aids in this process. A tadpole may transform itself into a frog in about 6 weeks. Perhaps one should take into account that the growth phase must be accelerated for the sake of the plot. This is reasonable to a point. Such a massive change in less than 24 hours begs credibility, however. Another place to see this is in those stories involving cloning. You'll notice that the clones tend to be mature incredibly fast, not just between fertilized egg and baby, but then to whatever age needed to catch up with the main characters. As far as I know, current research leans towards slowing or stopping the aging process, not accelerating it. The clones almost always are grown in a clear tank. There was something recently on Anton Petrov's YouTube channel where he discussed a type of artificial womb, but wanted to be perfectly clear that what was growing was non-viable. Others may know more on this subject. This was another ghoulish feature of the film Aliens and The X-Files. Supposedly human cloning is outlawed, but we shouldn't be surprised when China or North Korea announce this accomplishment in the near future. Maybe these tanks contain some kind of miracle grow for humans. What is the fascination that so many have with the manipulation or fabrication of other beings? Are only males possessed by this obsession since they cannot give birth? The Greek gods and goddesses could do it. Dr. Frankenstein could do it. Of course, slavery is a never-ending scourge on our species. Recently, I sat down to watch the 1977 version of The Island of Dr. Moreau, since I had never read it or seen an adaptation. For a book written in 1896, the concepts were quite advanced. The scientist was essentially trying to alter the genes of his subjects 60 years before Watson and Crick knew the structure of DNA. He was practicing a kind of gene therapy on his unwilling subjects. Wells was way ahead of his time, as now we have those who push gene therapy on a mandatory basis with no more justification than Dr. Moreau can muster. H.G. Wells was, however, a Fabian socialist in the heady days of eugenics. It is difficult for me to see which side he was on, the helpless animals of Dr. Moreau and the Morlocks in the Time Machine, or the elite. As a socialist like Dr. Moreau, he felt that the poor downtrodden must be elevated, but only to a point. Moreau's tortured creatures were to be changed from animals into men, or in the case of Michael York, from a man into an animal. York's partial transformation, as punishment for disobedience, from a single injection was also very rapid. In the end, these unwilling subjects must follow the elite and their maniacal penchant for social engineering. We must also consider our anthropocentrism with respect to robots or artificial intelligence. Why are some so bent on building robots with human features or even human responses and emotions? The same could be said for those who anthropomorphize animals while maintaining a disdain for actual human beings. Is it some deep desire for control and the ability to create a perfect human companion? One might say the same of the gods, who always have human form. If they are gods, then they could take any form they wished. I find robots that mimic human behavior to be quite creepy myself. On the flip side, why would robots such as those in Spielberg's AI or Data from Star Trek want to be human when they are already far superior in many ways? Perhaps I'm old-fashioned, but the human form should be exclusive to human beings. Anything else is just bizarre. In between Dr. Moreau, Dr. Frankenstein, and AI, we have Star Trek: The Next Generation and the Terminator. This is where the cyborgs come in. From my experience, the cyborgs are thought to be evil, depending on how much technology they incorporate. The Terminator was a mostly evil robot with a human outer coating. The Borg began as sentient organic creatures, but were taken over by machinery with a loss of individuality. RoboCop's humanity was artificially suppressed, and he had to fight to recover it. Cyborgs are an interesting case. There is much current research in the area of integrating technology into human beings. Elon Musk's company, Neuralink, is making great strides, as are others. We are, thankfully, far away from the Borg at this stage. Will there be a point where the brain-machine interface becomes difficult to distinguish? It is an age-old question as to where consciousness resides. Could our souls jump the gap, a la Ray Kurzweil, into the World Wide Web to live forever? The wonderful work being done integrating chips into the human body is transforming lives. People are seeing and hearing, many for the first time. One shouldn't dream of slowing down such work or impeding these breakthroughs. The age-old question is how much transformation is too much. Can one person truly decide for another? We've had cosmetic prostheses for millennia, and now many are surgically enhanced. If one chooses freely to do so, they should be fully informed regarding the consequences. For others, irreversible mutilation is forced upon them without regard and without reason, other than harmful ideology. It must take an incredible amount of hubris for one to feel he or she has the right to reform another to some arbitrary standard of conformity. Again, it is that misplaced desire of some human beings for controlling others, physically or psychologically. Often both means are used.